I miss the booth.
Yeah, that's what my study hall girls were talking about yesterday. Missing the booth. That's nice. Equations we solved today are going to have radicals on both sides of the equal sign. So it'll up the ante a little bit, making them a little bit more interesting and give us some good algebra skills just to work on. As I said yesterday, I like these problems because they require you to pull all of the algebra we've done in the chapter, but also factoring, and it helps us solve these equations. So these are the types of problems that I like to do because they are algebra based. Graphing is fine, but getting to pull in all the concepts that we've been working on to solve an equation is a good math problem in the eyes of a math teacher, being able to use previous skills. So we're going to wrap up with two more problems with these equations having a radical on both sides of the equal sign. You have a worksheet tonight. The worksheet, you don't have to do them all. You've got a lot of extra practice though. But 1 to 13 odd and 14 to 20 all. So the odd of the first group and then the last problems. But if you want to do all 20, that's fine. I mean, no problem with doing all 20. It just gives you extra practice. So you are really good at solving radical equations if you did all of them. So I'm going to start with number 31 from the homework, and then we're just going to go right into the notes. But just looking at number 31, good refresher to go over with the rational exponent in the equation. So really yesterday, the homework was not only having radicals in the equation, but also rational exponents, because we know a rational exponent really can be switched to that radical form. So number 31, I thought was a nice one to look at. What's the first thing that you need to do with this problem? Riley, what do you think the first thing is that we need to do? Yeah, so we need to isolate the radical, or in this case, we have to isolate the rational, the fraction. So we have to subtract the 22. Keeping that 7/3. And then this is 128. So isolate, whether it's a radical or it's a quantity raised to an exponent. That quantity or that radical needs to be isolated. So the next step would be for us to get rid of that 7/3, which means we have to take it to the reciprocal exponent, which would be 3/7. And remember, it's an exponent, so the exponent on the other side is also 3/7. So Riley, when you have 128 to the 3/7, how would you rewrite that? Excellent. So the 7th root of 128 and then to the 3rd. And remember, the exponents cancel because 7/3 and 3/7 reciprocals cancel each other out. So we're left with 3x plus 5 and then the 7th root of 128 cubed. The 7th root of 128 is? Well, back and did the 3x plus 5 and then the 7. Okay, so you kind of flipped it. Okay. Does anybody know what the 7th root of 128 is? Malachi? It is 2, yeah. So it does work out nicely. Even though it looks like it's a really big number, that's 2. Malachi, does that 2 need a plus or minus in front of it? Thinking about the 7th root. No. Yeah, it doesn't need one because it's an odd root. And when the root is odd, you do not need a plus or minus sign. So it's just 3x plus 5 equals 2 cubed, or we know that 2 cubed is 8. So if we subtract 5, 2 cubed is 8, 8 minus 5 is 3, and then that leaves us with x equals 1. So if I check this really quick, just to show you the check step, I would have 3 times 1 plus 5 to the exponent of 7/3 plus 22 equals 150. When you check it, you do need to check it into the original problem. So go back to what you were given and plug it into that original problem. So we have, in this case, this is an 8 to the 7/3 plus 22 equals 150. So the cube root of 8 is 2, and then you have 2 to the 7 plus 22, which is 128 plus 22. And that is definitely true. I keep missing that 0 down there. So 150 does equal 150. So you can check that to make sure that you solved your algebra correctly. That's the great thing about equations. You can always check your work. Any questions on number 31? So we're using that rational exponent and the reciprocal property. So getting rid of the exponent by taking the reciprocal, but keeping it as an exponent on the other side. So it still remains an exponent form. Questions? So as I said, we're going to do 2 examples today. And those 2 examples are on page 40, which is where we left off yesterday. The last group of problems we did yesterday contained extraneous solutions. We had 2 answers, and sometimes one of those answers did not work. Now, sometimes both of them work, and then a few times both of them will not work. But in most cases, one's going to work and the other one isn't. We are going to solve equations today that also have extraneous solutions, and your homework will have extraneous solutions. But if you look at the 2 equations in example 5, you see they have 2 radicals, one on each side of the equation. Our goal is to solve this equation for x. I will say that these take a little bit of work. And you can zoom, and obviously you've got space. You might need to add a slide. But they do take a little bit of work to go through them. So I'm going to zoom in a little more here so that I give myself some space. So we have the square root of x plus 6 plus 2. On the other side is the square root of 10 minus 3x. The first rule is to isolate the radical. Well, when you have a radical on both sides, and that one side has a plus 2, that left side, there's no way that we can isolate both of them. Because I can't get rid of that plus 2, no matter what. Even if I take it to the other side, it's still there. So one of the radicals should be isolated. And in this case, the one on the right is isolated. So you do have a radical that's isolated. The second step is to raise it to the power, the same power on both sides, depending on what the root is. So we are going to raise each side to the power of 2. So that side, the right side, has the radical. We're going to raise that to the power of 2. The left side is a quantity. Remember, when there's a quantity, you have to assume that that quantity, or it's implied that a quantity is grouped together. A plus sign holds them together like glue. So I cannot individually look at them separately. They are a quantity together. And we have to square that other side. Now, Jordan yesterday said if something was squared, it really means you need to multiply it by itself. So we have to take the quantity on the left and we have to multiply it by itself. The one on the right, we know that the radical and the exponent cancel. And we're left with 10 minus 3x. But on the other side, I'm going to write the other quantity because we have to multiply this by itself. So if I'm squaring the quantity root x plus 6 plus 2, it means I have 2 of them. And here's where it gets a little tricky. I'm actually, I think, going to write this over a little further. So yesterday we FOILed our problems on the left side because we had a quantity that was squared. So over here you can see in example B, we had a quantity that was squared. We FOILed this quantity together, x plus 1 times x plus 1. That was pretty easy to FOIL. We are going to FOIL these two quantities together that have radicals. We're going to take it one step at a time. So we're multiplying the square root of x plus 6 times the square root of x plus 6. When you have a square root and you multiply it by itself, the radical cancels and you're just left with x plus 6. So when you have a square root and you multiply it by a square root, I'm sorry. Addie, are you okay? Yes. Okay, go with that then. Okay. Okay, run and go get it. Are you okay? Okay. All right, I'll talk to you later. Bye. Sorry. My daughter never calls, so. Okay, I'm sorry, everybody at home. My daughter called and she never calls me, so I wanted to make sure everything was okay. All right, so we have a square root of x plus 6 times the square root of x plus 6. When we multiply a radical by itself, the radical cancels, and we just have x plus 6. The second thing we need to multiply is the square root of x plus 6 times 2. Remember, we're FOILing here. That 2 goes on the outside, and then we have the radical x plus 6. So it's 2 times the square root of x plus 6. Then we have our inner terms. Again, we have 2 times the square root of x plus 6. And then finally, my last term is the square root, or I'm sorry, 2 times 2, which is 4. So that's a lot. It's a huge problem. If you look, combine your like terms together. So we have this huge problem just on the left side. Combine your like terms together. So Faith, what do you notice that we could combine together here?
The 2 square root of x plus 6.
Yeah, so there's 2 root x plus 6 and 2 root x plus 6. So that makes
4.
Yeah, so that's 4. What else can we combine?
6 and 4.
6 and 4 add together to be 10. And then we still have this little x sitting in front. So we combined our like terms, the 2 square roots, and then we combined the 6 and the 4, and then the x was by itself. All right, we got rid of 1 square root because there were 2 in the problem, but there's still another one sitting here. Here's my other square root. That square root needs to be isolated so that we can continue to solve. Remember, the whole goal is to get x by itself. Well, when there's 2 radicals in the problem, that means you kind of have to go through the process twice. So we're going to, on the other side, we're going to move everything away from the radical. So I have the radical part boxed. The rest of it, we're moving away from the radical. So we're going to subtract x. We're going to subtract 10. So Faith, when you subtract 10 and you subtract x, what's left on the right side? Yeah. All right, the radical's almost by itself. It's so close. One more step here, Faith, to get the radical by itself. What's the last thing we would have to do to get that radical by itself? Divide by 4. So now we have the square root of x plus 6 equals negative x. All right, so just recapping what we've done so far. The first step, we squared both sides, but the left side we had to FOIL because we had a quantity. And then we combined our like terms, and now we're trying to get that radical by itself again because we still need to isolate the radical. My radical is now on the left side, and we need to square that radical. Well, whatever you do to the left side, whatever power you raise it to, we need to raise the power on the right as well. So you have to do this process twice because there are two radicals in the equation. So you have to isolate it twice. You have to square both sides twice because of the two radicals in the equation. When you square the left side, the radical and the root cancel, and we are left with x plus 6. Jordan, what is negative x squared on the right side? It is x, and then the x is still squared. So you're taking negative x times negative x. That's what negative x squared means. So you're multiplying it by itself. All right, thank goodness this problem is almost done. At this point, we have to take everything to one side. So my x squared is on the right. I'm just going to move everything next to it because I like factoring with a positive x squared. And then we need two numbers that multiply to be 6, but add to be negative 1. And that would be a negative 3 and a positive 2. Remember, when you're factoring, if there is a 1 in front of the x squared, that's the shortcut method. So take your two factors, place them in parentheses equal to 0, and then solve. So x is 3 and x is negative 2. Are there questions? I'll kind of zoom out so that you can see the whole problem. It's a big one. So the last step of this never-ending problem, I'm going to erase just so I can see the original problem, is to go back and check. So now, after you've done all the work, we still need to make sure that both of these are the solutions. You need to check it into the first equation that you are given, into the original problem. So back into the original problem, 3 plus 6 plus 2. 10 minus 3 times 3. That's plugging in the 3. And then negative 2 plus 6 plus 2. 10 minus 3 times negative 2. So you need to plug in each case. So when I plug in the 3, I end up with the square root of 9 plus 2. On the other side, when I plug in the 3, I end up with the square root of 1. The square root of 9 is 3. Does 3 plus 2 equal 1? 5 does not equal 1. So that means that my answer of x equals 3 is extraneous. Checking the other one, I have the square root of 4 plus 2. And then 10, negative 3, negative 2, that makes 16. Square root of 16 is 4, and 4 does equal 4. So my one solution is x equals negative 2. So that's like a 20-step problem. Holy cow. Does anyone have questions? I think the hardest part is understanding how to foil that radical together. That's pretty tricky. So what I'd like you to do is see if you can start B. Try and look at what you did for A. Do the same process for B. So the first thing, I know I erased mine, but the first thing we did was square both sides. For those of you at home, please let me know if you have questions. These are pretty involved problems. Especially with the foiling process. Any questions that you have? So as you're working, you see that there are definitely similarities between the two. After you combine your like terms, you take the numbers to the other side, you should be able to divide the radical by 2. And then we have that negative x left on the right side. Very similar to the other problem. So square both sides. And set it equal to 0. So hopefully you found that x is 2 and negative 1. Questions? Anybody have questions? So doing a quick check step here, going back to the original problem and plugging this in. We have the square root, 2 plus 2, and then plus 1. 3 minus 2. Negative 1 plus 2. And then 3 minus a negative 1. And I can see 2 plus 1 is 3. It does not equal 1. So I'm going to cross off x equals 2. But when I plug in a negative 1, I end up with the square root of 1 plus 1. And on the other side, I have the square root of 4. And that is 2 equals 2, which is a true statement. Once you go through it the second time, it's not quite as bad. At least in my mind, it's not quite as bad. Questions? So I think what makes the rest of this year challenging, I'll say the next 3 chapters, is that it has problems like this in it, where we have to use concepts that we've learned before, and we're applying it to the new concepts. And that's how trigonometry calc works, and that's how AP calc works. So like moving on, like math just builds on itself but you already have the challenging concepts, and then you're learning new challenging concepts, and you have to apply the old to the new. So it's always using what you learned and applying it. And not a lot of subjects work like that, but math definitely builds on itself. So if you want to go to Google Classroom, we're going to see if we can pull up the worksheet that you have for homework. If it hasn't posted yet, I'll make sure it posts for you. Looks like it should have posted, but it didn't yet. All right, so refresh, it should be there. So solving square root equations, these are all square roots. So there aren't any cube roots, there aren't any rational exponents, they all involve square roots. Do you see it on your end? Yes, okay. Apparently I don't have it on my end. So again, you're doing 1 through 13 odd. So make sure you remind yourself 1 to 13 odd. And then you are also doing 14 to 20 even. So 1 to 13 odd, 14 to 20 even. And we have 12 minutes. I think you could probably get 1 to 13 odd done pretty quickly. Because they look pretty straightforward, like just looking at those. If you want to look at number 9, just taking a peek at number 9. We have the square root of 3 minus 2x equals the square root of 1 minus 2x. We have a square root on both sides. If you square each side, what happens with the square root on each side? Riley, what happens? Yeah, they both just cancel because it's just a square root, not like the problem we just did where you had that extra +1. So that one is number 9, pretty straightforward. So the square roots cancel out, and then you're just left with the stuff underneath, the quantities underneath to solve for. So again, I think you probably can get 1 through looking at 11 and 13. I'm guessing you can probably get those done. And then 14 through 20 gets a little more interesting. Number 19, I have worked out, I'm sorry, number 18, I have worked out on the answer key. So I worked it out for you so that you could kind of see how to do 18 and 20. But I will tell you for number 18, you have to move this to the other side first. But again, I have it worked out on the answer key. And I'm going to change them into square roots. So number 18 would say the square root of -3 minus 4x equals 1 plus, and then the square root of 2 minus 2x. And then it's exactly like we did in your homework. So you have 2 problems tonight on this worksheet that are big problems like the 2 problems we did in the notes, not the homework, I'm sorry. And again, number 18 is completely worked out for you on the answer key, so you can use that to check. So if you're at home, if you want to remain on and ask questions, feel free to do so. You have 10 minutes to get this started in class. Tomorrow and Friday, we will be reviewing for your Chapter 6 test, 60 points. So that's tomorrow and Friday. Does anyone at home have questions? So feel free to stay on, or you are welcome to go if you're at home. Have a great day.